Hello, everyone. Thank you for being here. Today, I will be presenting my PhD project, which is Griffin, a storage service for granular edge applications. First of all, I would like to give a short introduction about myself. I'm Julia, and I'm a starting PhD student in Vrije Universiteit in Amsterdam. I work in the at-large research group, which is focused on distributed system research. And in particular, my area of interest would be networking, storage, and edge computing, which is the reason why I'm here today. So at this point, I think I should give a quick introduction on edge computing, even though I'm sure that it's something that we're all familiar with. I think it's a term that is quite hype at the moment because for all the use cases and new applications that it can originate. In general, it falls under the umbrella term of cloud computing, only with the compute nodes and storage nodes that are placed a bit closer to the users in the territory rather than in the data centers. And main users of edge computing applications are, for example, autonomous driving or IoT sensor networks or smartphone applications. And all these applications produce data that then needs to be processed in edge nodes in order to deliver a short response time and a result with low latency. So a short version of the problem statement that gave origin to my PhD is that the response times for data processing need to be short, as short as possible. A slightly longer problem statement is that all the applications that I mentioned, the autonomous driving, IoT, sensor networks, smartphone applications are collaborative applications a lot of the times. And so it means that they need to share data among themselves, among different nodes in order to work. But the data sharing needs might be different across different applications. All of this happens on edge computing nodes and storage nodes, which are potentially heterogeneous in resources. We don't have a guarantee that in a certain geographical location, there would be the same infrastructure as some others. So we can't make assumptions on that. And this adds problems to, for example, the replication strategies and consistent and communication protocols. Even more so, there can be unstable network conditions when you communicate from the nodes to the end users or between the nodes, for example, for replica placement. But still, the goal in the end is to offer low latency response to the applications. And this originated the research questions of how to do that. So how to offer a low response time. What is a good abstraction that can serve data and different kinds of applications in a single storage service? What consistency guarantees do these applications need? So do they all need strong consistency, or can it vary? So how to handle replication in different storage nodes and how to evaluate all this, because there needs to be a good benchmark for it. And these are all the research questions that I want to focus on with Griffin, which is a distributed storage service. And we aim at implementing this, offering different consistency guarantees to applications should they need different ones. Also offering an expressive API so that the different users can still have their needs met within a single storage service. And what we thought for addressing the problem of low latency is to support in storage computation for the application so that some results can be computed in storage instead of transferring to compute nodes. We took this heavily from the granular computing idea and new term that is being proposed now for mostly data center workloads that consist of short-lived tasks. So for example, microseconds that then cannot be really deployed on infrastructure that is currently typical of data center nodes, which takes, for example, milliseconds to deploy. We thought that this is applicable as a comparison to the edge computing use cases where, for example, the infrastructure might not be as high resource as the data center ones. So we cannot really support heavy virtualization environments to deploy a storage service. So, and since the response time should be low, it it's ideal to have something that can deliver results within microseconds rather than milliseconds. So we want to take the granular computing idea and go and translate it to the edge computing use case so that we can explore how to offer a low-cost deployment infrastructure and possibly use in-storage programmability, allowing users to reduce the communication between different nodes so that the response time eventually can actually be reduced for the end user. And the research plan for my PhD is to identify a proper benchmark, investigate the consistency requirements, find the suitable infrastructure that can fit the granular computing goal and use case, and then to evaluate. Thank you for your attention. Now I would like to take questions if you have any.